So a rough agenda of what we've got today. We've got quite a bit to get through. We've got a review of a bit of OEM panel production stages. Then we'll have a look at the introduction into what is EPlan ProPanel package and the outputs you can get. We'll have a look at ProPanel manufacturing advantages, including going into weight and other metadata that belongs in part data, RI panel configurator and RI power, placement, collision checking, mounting clearances, some thermal calculations and visualizations, cooling zones and airflow, drilling pattern outputs, and right-tail Perforex automation, as well as other drilling machines, cutting lists for DIN and duct, wire number lists and exports, and then wire routing and connection lists with lengths for wire production, trunking fill capabilities and capacities, and copper bending and pipe bending. And finally, some of the other outputs, including 3D PDF outputs, STP exports, and CAD utilization. And then I'll cover roughly the smart production opportunities that can be gained from ProPanel as well. So as we work through these in chunks, I'll be referring back and showing you where you can actually get those advantages in manufacturing and streamlining in manufacturing. So to have a look at the traditional kind of OEM panel production, which I've done a bit of myself, from a job, once the schematics are kind of completed, you go through an ordering process where you start ordering your panels and parts and all the accessories, your wire rolls, etc. And then you've got maybe 4 weeks of dead time waiting for parts to arrive while nothing can really happen on it until you get your panel, until it turns up in the workshop. Then you've got your marking, drilling, and tapping of the panel for all the DIN and duct. That takes I've got it here as just less than a week. And that's all manual work. We used to do it with a bit of masking tape. And then from there, you'd start mounting all your DIN and duct onto the panel. Then sequentially after that, you would put all your devices onto the DIN and duct, onto the DIN rails. And then you would start with your wire labeling, crimping, and terminating into the panel. And this is very sequential work historically, in that it would be done one after the other. And with one large panel, you'd be looking at about, say, 3 weeks worth of work. That can't happen until the panel's been delivered to you. Now, where we're aiming for here with ProPanel is if I show you a change of this and start to parallelize the work up in terms of you get events happening in parallel, or you disjoint the work so you can take care of some parts earlier or at different times, and also implement a lot of automation that's provided to you from ProPanel. So what we've got is, at the start here, we still have the ordering of the panel and parts, but now there's no longer a need to wait for the pre-cutting of the DIN and duct rail, for the DIN and duct rail. You can actually pre-cut your DIN and duct rail to lengths and have that stored aside, ready to be mounted on the panel directly as soon as it arrives. And this obviously takes less time than the full manual marking off and pre-cutting. You're just measuring to lengths, versus comparing back and forward to the panel. Cutting and labeling or outsourcing wire production can happen, disjoint as well, in terms of you have your complete wire lengths, and you can outsource this for someone else to produce all the wires required for your panel and receive them pretty much as a bag, ready to put into the panel as soon as it arrives. And this can actually fill in the dead time between ordering the panel and when your panel arrives. Once your panel arrives, you've reduced the workload past that point. So you have automated panel machining, and that's why I've got it in blue here. So what happens with that is you can use machines such as a Perforex to automatically drill and tap your panel. Again, increases accuracy, speeds up the process, can be done very quickly. And then mounting pre-cut DIN and duct rail, if they're marked up and you have a guide, you can put them straight on without, seamlessly, very quickly, without errors. And then mounting your components on, which I've got at about the same time because that's just a process, and then followed by installing prepared wires. So using a wire guide, you can put the wires straight into the panel, and there is, of course, the smart production, which can show you where to terminate it to and from. And this speeds up time because there's no crimping and stripping involved. It's all been done previously, and you're just working to the wire numbers. So you can see overall here with this plan, it's filled in a bit of dead time between ordering and delivery, and it's also sped up the whole process and included automation. So looking at the ProPanel package and some of the advantages, ProPanel comes in a standalone version, or it also comes as a ProPanel as an extension for P8. And within ProPanel, what you want to achieve is getting your schematics done, correct parts, with all their parts and metadata, which we'll show you soon, 3D panel layouts and getting that correct, as well as wire routing done and complete. And from that, you can start generating some of these advantages, including digital twinning and virtual assembly testing. And this is something I'm going to talk about quite a bit today. And by doing that, what I'm saying is you're testing the assembly and design concepts you haven't had to think about until you've actually received the panel. You can now come across and figure out a solution for ahead of time and plan for, so you don't get that dead time or don't get any surprises in a virtual assembly environment. Cutting lists for din and ducting, we've talked about. These you can generate, you can cut all your din and duct, have it ordered, have it cut, usually from a local supplier, which is nice and easy, and ready to go, sitting in a pile, waiting for the panel to be arrived, pre-automatic drilled and tapped. There's some other advantages from the metadata for parts. You can generate panel weights, a report with a summary of panel weights, and this can help with shipping. And also with some of the other panel part metadata, you're able to check mounting and clearances for your parts to make sure you comply with all the thermal requirements and the legislation for your panels. The drilling outputs is what I talked about in terms of automated machining. We'll go through those and show you how to set it up and how it all runs. And connection lists with wire labels and lengths. So completely generated with every wire number and the length of each wire beforehand as another output, obviously. And then thermal summaries to use in the Rytherm, which will generate your thermal reports and also aid you with your Rytel thermal part selection in terms of whether you're using an air conditioner or what fan size you need in terms of volume of air. And all this can kind of help with your saving time on the OEM production of the panels. And EPlan Smart Production Suite is something that I'll just touch on at the end, which is a further extension to all this and the ProPanel advantages. So EPlan ProPanel, it's literally designed for manufacturing outputs. I've been working with ProPanel for a bit over 3 years now. When I first started with it and started doing 3D panels, I thought it was lovely to do beautiful 3D looking panels. But it's so much more than just a CAD package, and it's so much more beyond just the 3D graphics and the pretty looking panels. It's a virtual panel assembly platform. So you're actually assembling panels completely with manufacturer's parts and data in an environment that is taking care of a lot of design considerations and will speed up the production once you get to that bit and assist in the automation. So the first section I'm going to look at is looking at some of the metadata of parts. What we have here is weights and internal data. So EPlan parts in the parts database have many properties. Some useful examples include weight. Others company specific, like you can actually hold your ERP number for your stock system in your parts data. And these can be used to and totaled in a report, giving you a summary or cumulative weight. And weight is just an example that can be used, say, for shipping when you have to order the postage of your or courier of your panel once it's complete. Other data that's included is the Rytel panel config. This is actually an application that's provided by Rytel and exists in the EPlan cloud, but you also have access to it through the data portal, the EPlan cloud data portal, which is through EPlan as well. And from this, you can configure your panels before you even start. And this will aid in both having the correct accessory list for your panel. You can put on sides, backing, mounting lights, mounting rails inside. You can change the plinths. And this ensures, obviously, you've got the right parts that go with the right panel. It snaps them on to save you having to manually place them in ProPanel, and saves with accessory placement. And you can also put cutouts if you want, which carries through. Another possible config tool that's available, it's temporarily disabled at the moment with its direct EPlan interaction, but this is RyPower. And RyPower allows you to configure things such as the Ryline X range, and it's been begin updated, so they're starting to update things. You can choose the Ryline X parts, it's all in there. You can clip them on, you can build up systems, and this will eventually be able to export directly and be placed directly back into ProPanel, straight onto a panel. It functions similar to the panel config software, and yeah, system configurations are directly imported with all parts lists, correct parts lists, so you've got no hassle with mixing up parts. And lastly, another bit of this auto config system is the placement collision checking. So when you go into place parts within ProPanel, to help with the design checks and obviously with digital twinning and this virtual assembly, you can turn on placement collision checking. And when you're moving parts around, if there is going to be a conflict, say with the backing of a fan hitting the duct, or say the VSD being too close on the panel to actually hitting bits on the front of the door, all these will actually come up and show you in red and say, this cannot happen. You're not allowed to place this here. There will be a conflict. So you know everything is going to fit absolutely beautifully when you finally produce your panel. And I mean, this saves in errors, because if you do get an error when you finally get to the production, you've got things cut out already. You're thinking, oh, how am I going to fix this? How am I going to change the placement? How am I going to adjust? So you've had to deal with all this before you get to that stage. So I'm just going to jump into a bit of a live demo now and just cover these first bits here. Let me just, and yep, just jump across to EPlan. So the first thing I'm just going to show you is with the data portal and the panel config. Popping that open, I can go to EPlan Cloud, data portal. Unfortunately, on the first page that loads on this data portal, we have a panel that can be configured. Obviously, there's a bit of a lag with the data portal because it's now at, I believe, 2.1 something million parts. Here we go. Yep. Yeah. So this second panel here on the front page, if you want to run through this yourself, can just be configured. So you can go through the configurator, and this will load within the data portal. Yes, continue. So working through the stages of this, it's already got my enclosure. Just skipping to next. I'm not going to run through this in a lot of detail because this is something you can experiment with yourself. So I'm just going to add, a couple of parts like side panels, and adds them in. A plinth system. And a system light. When part of the beauty of this is it comes in fully assembled. And when I first started working with these kind of bayed enclosures, trying to get these side panels, getting the right one mounted on the door within ProPanel, this takes care of everything for you, and your panels are quickly ready to just drop in. I'll go to next. I'll just skip through this pretty quickly. Here you can add other cutouts and drilled holes that carry straight through to ProPanel. Next, we'll give you a summary. And then finalize towards forward configuration. And you have this option here to drop it straight back into ProPanel. I'm not going to click on this live here because this is actually a long bit of the process and orders everything to be assembled in the background in the cloud. And then you can drop it straight into your page in the background here. But this exact panel with that exact config I've just shown you, I have an example here. And you can see it's put the light in, it's put these side panels on, good to go. So it's a beautiful tool. Right Power is in the cloud. Get EPlan Cloud. Obviously, you just search Google EPlan Cloud, top search results, log in, and I'll go to my dashboard. All right, and it's just here, right power. This will eventually be available through the data portal as well. So going back to ProPanel, I'm just going to have a quick look at some parts data. So if I was to go into my master data and open up parts management and go to let's go to electrical engineering, accessory, sorry, not assemblies, components, protection devices, through circuit breakers, have a quick look at Siemens, have a whole heap here. I'm looking for, let's go 5SY 402. Two bingo. So if we pop one open here, um, all we can see is the properties of it. And it comes through like this from the data portal directly when you download it. Obviously, it's populated with a lot of the metadata already in terms of height, width, and depth. Two other properties that we want to look at is weight. Weight displayed in unit has actually come through from the manufacturer. So it saves you having to find this data from data sheets and manually enter it. So it's nice to have that available for all your parts you download direct from the data portal. If I was to have a quick look at the paper space and under reports, weight report, you can actually generate a report. This is all the parts that's listed in a demo panel. I'll just show you the demo panel quickly. This demo panel here is what we'll be working through today for a lot of it. And this is just a item list of everything inside, and it takes the weights of all the items and sums it up and gives you a cumulative weight for that panel. Last thing I want to show you, just jumping back into that layout space and having a bit of a shift around, you can turn on and off insert, and then up in options at the top here, you have your collision check. So if I was to show you with it off, I can just take, say, a fan, copy that fan and paste it back on the side, and it will actually let me place it where it overlaps. When you have collision check turned on, paste the same fan back in. As soon as it becomes overlapping or conflicts with something else, it'll actually give you two red fans saying, look, this isn't going to fit there. It's not going to place there. And you can use this check as you're placing or building your panel to ensure everything's fitting nicely. So obviously the advantage, as I said, with digital twinning and this virtual assembly method is you can highlight problems and find problems and with your part selection and prevent errors or reworks once you get your panel delivered and take care of things virtually beforehand. So the next section I'm going to run through is mounting clearances. Parts have mounting clearances as data. They have it in all 6 variables in terms of above, below, left, right, and front and back. Some parts data have this from the manufacturer, some don't. So it's a matter of checking your parts. And as I said in the previous webinar, it's about consistency in terms of if you have your parts correct, the ones you regularly use, it'll carry forward and then you don't have to do it twice. And this has also got a graphical view where you can see the mounting clearances on parts. And then the thermals. So there's a number of thermal views that are available in ProPanel to check the thermals for your panel. There's airflow, which is shown by the arrows, the red and blue arrow you can see here. And it has optimal cooling zones for elements like air conditioning. So obviously when you're doing your planning, you want to make sure that you get your VSDs or your cooling is covering where your VSDs are actually going to be placed to ensure that everything's kind of lining up that way. There's a concept called air conditioning fields where devices can be collected, and this is designed to have multiples in case you want to create a batch system with different zones, like thermal zones or different heating zones, cooling zones, obviously, but it'll actually generate and calculate all your thermal data for your panel, and it'll allow you to take that value and pop it through Rytherm, again in the cloud, to generate your thermal reports for your panel. All right, so just jumping into this, showing where you can find it. If I was to pop open the parts data again, let's just hide the door on this thing, and then open up my VSD and have a look at the parts. And what I'm going to do is just under properties, I'm just going to type mounting. And just here, you have your mounting clearances. So obviously for this one, I've already got it set up. But some devices you'll find it's not here and you'll have to find it. But once you've got it in your parts database, it carries forward with the part every time you reuse that part as well. Another thing we want to look at is for the thermal calculations, your part data will need to have this field here, which is max power dissipation. Now this auto calculates in terms of you can have watts just in here, or you could have 0.2 kilowatts with the kW, and it will auto convert it back and understand it with the units attached if you put it in there with units for your parts data. Yeah. Do not save data, do not save changes. So the first view I want to show you, they're under view, is the mounting clearances. So for this panel here, we've put it in for all the parts that have it. This is a thermostat in the top corner. Obviously, it requires a bit of space around it to make sure it's not directly heated. And then you've got your VSD down the bottom here. And these aren't just 2D fields. They're actually 3D objects placed around every part. So this is your mounting clearances. And obviously, I've designed this panel keeping these in mind, so everything's sitting pretty neat. Another view we can show you is the power dissipation density. Turning this on will automatically color all your parts depending on the amount of power they dissipate. And this way you can see obviously parts like this GPO doesn't have a power dissipation, nor does the passive thermostat, but everything else does fit in. And red devices obviously are your larger power distributors, your larger heating elements for the panel. So with this parts data and the thermal data, you can assign parts. This is a power supply to be part of what's called a air conditioning field, and it's shown here under the properties of the parts if you open it up, and this is assigned to air conditioning field 1. Now the reason it has that is because your panel itself has the same field. So if I was to look under my layout space here and look at our panel, our enclosure, and go properties, this has an air conditioning field, but what it also has is where you enter your temperatures. So maximum external, maximum internal, minimum external, and minimum external. And anyone that's done thermal calculations knows that this is a common property to have for your panel. You need to figure these out or have them on hand. Once you have all your air conditioning fields set up and all your devices allocated to the correct air conditioning field and your values for your temperature, you can run through the tools, and up here under generate reports, it allows you the ability to calculate total power dissipation. There are a couple more settings I'll show you in a second that you probably want to set first, but I'm using the default values for those. But just running through that, we'll run the calculation, and it will show you which air conditioning field zones you've used and allow you to select them. So obviously that one's there. I've already run the calculation for this. Once you've run it, the way to actually get that value is to go back to your project and look under your project properties. So I'm back in my paper space here, under properties, and this usually has all categories, but I've just reduced it down to the thermal design for this project. The properties I was talking about that you may want to set up first is your voltage, your frequency, and your simultaneity factor. And I've kept this at 1 for now because there is a second simultaneity factor that's applied, and that's in the actual Rytherm software. So keeping it at 1 for this, and then because I want my report looking nice and tidy, I'll have the actual, we use a 0.75, and that'll be in the Rytherm software. We use that. Yeah, and this is the calculation it produces. So when you rerun the calculation, it will change this value based on everything in the panel and the panel's conditions itself. So I know I've got 246 watts. Um, to access the right therm, again, that's in the cloud. So it's just down the bottom here through your data port, through your EPlan cloud. You can pop that open and then run through the process. I won't do that today because it's almost a topic for a whole nother webinar. But what I can show you is, when I get back to ProPanel, is you can re-include that output, the PDF generated from your thermal, back into your project. And I've got mine here. Just pop that open. Toby's going to have a little bit of a complaint, but there we go. So I've got my minimum and maximum temperatures. I've had to enter those, but I've also set the same ones in the panel. Your frequency and voltage. I've chosen my panel type. Obviously, it matches the enclosure from ProPanel, and it tells me down here that, you know, with my simultaneity factor, I've got heat to be dissipated as 41 watts. Power dissipation is 186 watts. And then here I've got a suggested cooling method, and it says I need 12 meters cubed per hour. And the fan I've chosen is these fan sets here from Ritel, and I have 15 meters cubed put through in terms of volume of air. And then it gives you a bit more details. Yeah, entered simultaneity factors, the 75% I told you about, with a total of 247 watts, and then that resulting wattage. And then it produces you a nice graph as well. So all that comes through as a nice report that you can include back in your panel design, back into your project in the paper space. Looking at the last couple of views under cooling and air conditioning for your design concepts. If I was to pop open, this is another panel we have with an air conditioner. This is actually our display panel we have here. And I can just hide the doors. And then looking at that, I can change the views. I've got no views enabled at the moment, but what I want to look at is airflow directions. Because this is the only cooling unit and no fans in the panel, it's given me a red arrow for the intake and a blue arrow for the output of this air conditioning unit. These are 3D arrows showing the center of the cooling and the vents. Another option you have besides air directions or flows is the optimal cooling, conditioned areas. So you can see this is like a 3D object of a cone of showing you where the major cooling areas are generated by this air conditioning unit. And ideally, this would be situated a bit lower, or we would have our drives stacked in that area to make sure our drives are probably the largest heating element in this panel. Let's just have a quick look. Yeah, so drives are red down the bottom, and that's kind of where we'd want to overlap and use this as a planning tool. Alrighty. So obviously production advantages is mounting clearances can be, entered correctly. You can look at them, you can check them before you place things on the panel, you can plan around them. Thermal aid and helps in compliance and ensuring panels are mounted to regulations. So everything's done correctly. You've got the right cooling, you can produce your cooling reports, and you've done all your due diligence in terms of that when you're manufacturing this panel. Next, we're going to have a look at drilling patterns and outputs. Parts in ProPanel come from the data portal, usually with a drilling pattern to mount onto the mounting panel directly, or onto side panels. Cutouts can be carried through. They're considered drilling patterns as well. And these can be output as well. So when you've completed your panel, you can output, say, a DXF file for either a Perforex machine from Ritel, or there's other formats you can export that will allow you to use nearly any laser cutter or digital drilling and machining tapping machine to produce automated panel cutouts. You can customize machine profiles and save them for different machines, or say the different couple of suppliers that'll do your cutting out. You can save their machine profiles or what files output setup works for them within ProPanel. And it's auto-generated from the layout space. So once you place your parts, you're not going through and manually adjusting a lot. It's designed to be very seamless. So the drilling patterns are held in the parts data and can be manually added and cut out from most shapes are possible. Yeah, you can cut out almost anything, including, keyholes for buttons and for door isolators, etc. This here is a Perforex machines, is the Rightail one. It's a beautiful one. There's actually one at CSL as well. They use this quite regularly, and I think they can provide services in terms of if you've got your machine, your ProPanel done and you need them to cut it out, it can save you a lot of time. I've seen this thing do a 2 meter by 1.5 meter panel in all of about 20, 30 minutes compared to, it takes a day for someone to mark it out with masking tape like we used to do back in the day. Alrighty, so jumping back into ProPanel to show you where to find all this stuff. If I was to go back to our panel, which is a reduced and simpler version here, and look at this VSD, I'll go to parts and open the part itself, and this is my parts database. And in here, I'm just going to type drill. Oh, no, sorry, it's under manufacturing. Ignore that. So it's down here under manufacturing, and you have a drilling pattern. So this drilling pattern is almost its own part data, and it's saved or associated with this VSD. It's the overview of this has 00 as an offset. I'm not going to go into details too much on this. This is obviously the properties of the drilling pattern, and it has cutouts in terms of this one's requiring 3 threaded holes. It's got the X and Y position of the threaded hole, and it's a 4mm threaded hole it's suggesting. So this is actually provided by the manufacturer, and there's no reason you can't create custom ones as you need them. So with that, just canceling back out of this because I don't want to change anything at this stage. You have an option to view the drilling views, view the drilling patterns. So I've got the view menu open here, and I'm just going to click on drilling views. And what this is doing is showing me the drilling views for everything, including my trunking. There's actually some drilling points at the top there for the earth bars and neutral bar. But if I zoom on this VSD, you can see it's got 1 drilling hole at the top and 2 down here at the bottom. And they're the patterns that carry through directly onto this back plane. From this, to carry this forward to your project, so your engineers or assembling guys can have a look and understand it. Popping open my paper space, I've actually placed a 2D drilling view window, and shifting this around, you can see here, this is just showing me all the drills and cutouts required for the panel. So here you've got your neutral bar and your earth bar with its drilling holes. Down here is the VSD that we just looked at with the 3 holes, and then our trunking and din rail. And also our door and our fans. So you've got the right side of the panel here with your fan cutout. Again, fan cutout provided by manufacturer. So this is provided by Rightail. It's perfect sized. It'll fit every time your fan will clip in. And if it's automated in terms of the cutouts, there can be no errors. And it's seamless from manufacturer straight through to assembly. Same with a lot of these door cutouts. There's a couple of Siemens buttons here for start, stop, and reset. And e-stops as well as isolators. The whole lot carries through from manufacturer straight to placing on your panel, straight to automated cutout at the bottom here as well. So from this exporting these, what I would usually go through is File, Export, and you're looking at machining. So at the top here, with the ability to export machining for different Rightail machines, the BC is the drilling machine, drilling and tapping machine, like the Perforex that you saw. There's another Perforex, which actually is the laser cutout, a bit faster, but obviously can't tap holes. And then you can export DXFs directly. And these DXFs can be used by a lot of manufacturers and still produce these cutouts and automate your cutting out process, which can be outsourced. The Rightail processing center is a bit more complex. That actually it's a production management system which talks to various machines and manages it and passes the panels through. These top ones produce specific files for these machines, but the DXFs will actually come out as one file per panel. If I was to say choose a output like a DXF, what it will do is it'll pop up here, and this is where you can actually select your machine. Now, what we've done here is in the early days of using the Perforex, before we use the Perforex files, we customized some CSL Perforex machine profiles, and you can actually save these. We did one with text and one with no text on the outputs, and you can customize everything from, drill holes, drilling exceptions. If you don't have a drill bit, you use one larger, one smaller, etc. And this is heavy manufacturing selection for your auto production, and you can save these. These also, which is quite cool, can be exported and imported. So we can export these and say, okay, this is the DXF setting if you want to use CSL's Perforex, and then you can import it directly, and then you're good to go because it's a tested machine profile. Obviously, output directories, etc. So in terms of output files, the DXFs that it produces, here we've got a DXF that's just opening in a DXF viewer. We can see all the holes it's carried through from this is a bit of DIN rail sitting here. We've got our vertical trunking, horizontal trunking up the top here. If I was to open one with other DXF files, down the bottom here, say like the door, again, we can see the same cutout. So it's in the 2D view carried forward. And these files are to scale and DXFs, which can be used directly. I've also reinserted them in the project, which is a quite cool feature of EPlan. So I can keep them with the project and they'll carry through. All right. Obviously, the advantages of this are clear. You can automate your drilling from this. Parts data, as I said, goes directly from manufacturer through to finished automated drilling, and that your part's going to clip in, they're going to fit first time. There's no manual marking, no manual work on the panel or on the enclosure, straight to finished product, and it removes the chances of errors. Once you've got something that works, you can reuse it, and it's going to work every time. And it's not going to be a question of, are my fans going to fit? Is it going to be messily drilled? Is it going to have, scratches on the panel outside or anything? Alrighty. Getting into cutting lists, there is a way to capture cutting lengths of 2D panel layouts. It's a nightmare. Involves a lot of messing around with block properties and etc. But you can also in 2D panel layouts place actual part numbers. But to have to go through this and implement this took us a long time, and it's a hard way to go, and it's more of a guesstimation with a lot of chances of errors. It's definitely not suggested. But from there, actually moving forward into what is beautiful created by ProPanel, is you're able to drop in your DIN rails and duct rails as actual parts. And when you create a cutting list, it knows that in 3D placement, it is exactly this length as you've got it in your 3D object. It has the exact width and height. It's looking for any conflicts or any overlaps or any way it'll get in the way of doors or hinges or anything else. So it's definitely better to go through the ProPanel avenue for this. It'll do bus bars as well and give you all your bus bars links so you can pre-cut your bus bars as well as part numbers and generate reports. It's a good practice to give all your mounted items tags like UB for bus bars or UD for duct or DIN, and then UT for trunking. As long as you have a company preference, it makes it easier to sort and clarify in the cutting report. And all your DIN and duct rails are actually zero mounted, zero measured. So it's measuring versus, say, like on the large trunking, you've got the double holes. So everything's measured kind of off the zero of those double holes. So you know that you can cut everything off that and it will mount the drilling patterns exactly. You also, if you have a preference in terms of the drilling patterns for your DIN and ducting in terms of how often you want the hole drilled, or are you using pop rivets, or are you using tap screws or machine screws, that can all be entered as well. So looking at the DIN and duct, back to our panel. Obviously, you can see it already placed here in this panel. I'm just going to change the layout space to narrow it down just to our mounting panel. And I'll turn off drilling view. All right. So this is what I mean by when it places it, it actually does place the trunking exactly as it is from the manufacturer, with collision checking and everything if you have it turned on. You also have the option, they're used as extrusions, and what's meant by that is when you place them, you have the ability to say change the lengths of these and adjust them. So obviously that one's conflicting somewhere along there. I think I've got it mounted a bit close or overlapped it a bit, or it's over the holes on a no cutout area at the back. But let's turn that off for now. But you can adjust the lengths of them. And as I said, they've got drilling patterns. So if I was to open this up, this is obviously, it's a right tail part, right tail trunking. And this has a drilling pattern from the manufacturer that's guaranteed to work and good to go. And this is designed to have two rows of holes drilled. And you get options in terms of its repetitive spacing is 50 millimeters, but it's drilling every fourth hole. And that will mean it skips holes in between and drills holes at 200 millimeters, except when it gets towards the end spacing and of the end of the ducting or trunking, and then it will bring it back to the next closest hole. So your last hole might be 150 or 100 because it's increments of this to get one in the end. So that's quite clever the way it works around that, and you can customize it to whatever you need in terms of your manufacturing preferences yourself. So that's setting up the din and duct, placing it, extracting it, and then from there, the cutting list itself is in the paper space. I have a ProPanel cutting list here, and what it generates is it's got a legend item in terms of the panel. It's got your DT, the device tag. I've obviously used D for DIN rail and T for trunking. It has the part number, the exact part number of the manufacturing part. We use Phoenix compact DIN rails in this. It's got the exact length of it, so what length it needs to be cut, obviously to an extreme precision, but you won't need that. And it has obviously its function and a designation. These are reports, so these can be customized in terms of if you've worked with EPlan before, you can change what it's actually displaying or adjust the parts data if you want more verbose details in this for each part. One last thing is just a report filtering. So if you do create reports, you should be familiar with templates. ProPanel cutting list is obviously the name of the report. And then under the cutting list here, all I've done is specify if it has a DT of UD or UT, it'll actually use those to specify only those parts come forward into the cutting list. And other than that, it's close to just a standard parts list. So not hard to set up, easy to run, and accurate every time. So obviously this goes back to the first couple of slides where I was talking about pre-cutting your din and ducting. You can pre-cut it all, you can have it ready, and then you can see now that it matches up. It's from a manufacturer's drilling specification. If you use that or your own that's tested, you can have it pre-cut ready. The panel comes pre-automated drilled, and it will go straight on, saving a lot of time in production. Next thing I want to look at is the Y number exports. We get a request for a lot of our engineering we do to export Y numbers. This goes through obviously a label printer, a wire number label printer to produce kind of the little plastic tags that go into ferrules that get crimped on. And when you start doing this process in terms of the historical manufacturing, you would wait till you've got every part mounted. You'd start running wiring through the machine, and then you would manually like crimp each head and put in the wire number and then terminate. ProPanel expands on this in a complex way, but it ends up allowing you to create a completed connection list with length. This is the most critical characteristic here, in which case you can pre-cut all your wiring, you can pre-crimp it or obviously outsource it if you wanted, and then have it ready so that once your panel arrives and you have everything mounted, you just need to look up the wire number on the page and find the wire and then pretty much terminate it between the two devices directly. It saves a lot of time and it disjoints the work. It parallelizes the work so you can run it in parallel with it. Another property is trunking fill capacity. We've had some of our jobs where we've had requests that trunking can't be overfilled or can't be filled more than 50% to allow for future expansion. ProPanel is able to handle that as well. And it's got both a setting in terms of you can set its, fill capacity limit and warning. Obviously, these low values are just percentages I've put in for testing. And you get a kind of almost like a bar chart representation in terms of showing green bars for how full a particular trunking is. Just a quick image here for you guys. This is the Ritel wiring machine, and this thing's an absolutely beautiful. It's called Wire Terminal. What it will do is it'll pre-cut, pre-crimp, and label all your wires, and you get them out on assembly looms that you can just put straight into the machine. An alternative to that is a piecewise Ritel wiring system, where each of these bits of equipment can be purchased individually, and then we'll take care of an element of the automated wire production. So obviously this one here is measures off lengths and then allows you to auto crimp with this tool here that you poke the wire in the front, etc. So you don't need to tackle the whole thing at once if you can't outsource it, but there are options. So just showing you where this all is in ProPanel, and this gets a little bit complex. So I'm just going to start with the parts data. If I was to go back to my panel and pop open, say, one of these parts, like an MCB, nice and simple. The part data itself has something called a connection point pattern. Connection point pattern right here. And this is similar to the drilling parts in terms of it's its own part. It's its own saved property. And it has obviously properties of this connection pattern, but it has the connection points that belong to the device. So what it has is it has a termination point for every wire that has to connect to it. And a lot of these come directly from manufacturers. I know Siemens takes care of everything, so does Ritel, all its fans and everything. And it has an X, Y, and Z coordinate for that connection point on the 3D object of the device. It has a vector to say which direction that terminal is wired into, or that location is wired into. And it also has a preferential method of routing in terms of these ones that say move up is because it will try and wire it to the duct. It'll try and wire it from the duct above or route through the duct above, whereas the bottom of the device will try and route through the duct below. These connection point patterns belong to the device, but they can also be edited locally, and you can have a local connection point pattern. And this will mean if you use any unusual mounting, you can override this and then place it somewhere else, have it route a different direction. I know I can show you an instance where I've done this. And once this is done, like a flash package, you can go choose an individual device and choose to route that device. And what that's done is it's come out of the bottom of the device in the correct direction based on a couple of views. So under views, you can see your connection point designations. And this is a little bit graphics intense, but you can see the little red dots on every device showing the connection points. Obviously, this contactor is quite heavy with it. And you can see connection point directions. Remembering this isn't your wire directions. This is where the wire comes from, sorry, not your routing direction. So this is the MCB we looked at. The termination points at the top and the bottom, and the wires come out of it in that direction. As a contrast to it, if we look at, say, this network port at the bottom, these network ports, the connections to them come straight out the front. So we have wire routing. What would happen is once you've defined your connection, if I was to say, have a look at the connections on this device, you can view all your connections under your connection navigator. I can synchronize that device and then view the routed connections. What I'll do is I'll just show you what a completed panel looks like. So I'll say show all routing connections, and it shows me the whole lot. And I can have a look at this and jump back to the device in terms of get a graphic and see that device there, and go to counterpiece. All right. So this is my MCB here, but you need to define all your connections for this to work. So I've got colors for the wires, I've got cross-sectional area, and when this was created, none of these lengths were populated. What ProPanel has done is reverse populated all these lengths from the ProPanel itself once it's routed those wires. Where this is used is you generate a connection list. Just to show you the traditional connection list, we have no lengths possible. When we go to ProPanel, what happens is it lists every one of our connections, our wire numbers. It lists source, its target, in this report we've set up, obviously, the cross-sectional area of the wire color, and its length. And this can be extracted as well and fed into many different machines, as I've said. And this would just be under File, Export, Wire Fabrication. And you can see there's a few other ones defaultly supported, but also that wire terminal from Ritel. Or you can just export manufacturing data and export it as labeling with lengths as well to go into an Excel sheet that'll feed into nearly any wire processing machine. So one of the other outputs is trunk fill level. So if I was to say open, I'll just show you on, this is a demo panel here. And we can, I'll turn these off to decrease the graphics, but we can put in fill capacity. And this is the image I had earlier where it'll actually show you the fill capacity of each of your sections of routing. And you can configure this through your settings. And this is a project property. So I've got 3 projects open at the moment. Obviously, this is the demo panel, and under route at the top here, you've got fill capacity. I've set this very low, but yeah, and that'll indicate to you obviously when things get more overly full and give you warnings and change trunking to different colors. So obviously the advantages of this is pretty much the same as the din and duct rail and the din and ducting, in that you can get it, you can remove it from having to wait till you've got the last stage of production done. You can pre-cut, crimp, and label all your wires. You can have them ready in groups of color or whatever you need, so that once everything's mounted on the panel, you can put it straight onto that panel, and you're not waiting around. And it also saves time, because manually pulling off a roll of wire and then terminating like individually one by one can be a very slow process. Last section we're going to look at quickly is the copper bending and pipe bending. So ProPanel, it's a bit of an extreme case, but has the ability to do copper bus bars, and will actually bend them based on parts and what you set up, and will produce reports based on this as well. And this is obviously for your large power distributions. We got a demo panel here with an ACB, I believe, and yeah, and carries through straight to reports. The pipe bending specific only to the pre-planning and PNID or plant flow diagrams. So you can set those up, configure that, and have it produce pipe bending examples for you. And then the system exports. So you're able to export from ProPanel in either PDF. It'll put a 3D object in your PDF, which is useful. It increases the quality of your company's PDFs it generates, so people can look at it and say, oh, that's a cool panel. I can see what it looks like. I can roughly get a feel where everything's got to be mounted, and gain that kind of understanding. And it can also output STP files, which can open in other CAD packages and have a look at. So just to show you what these are quickly. An example of this would be, this is one of the copper bus bars from that panel. I can show you the larger panel. That's my mounting panel on there. Bingo. So you can see here, it's got quite complex bends, separators, drilling patterns carry through as well from one through the whole set. And then you can export just individual single bus bars. It'll generate a output DXF file, which I have an example here in Paperspace. And this is kind of what it generates. So this one we can see in the background here, we've got 2 holes at the bottom, a bend of 90 degrees, and then a couple more holes in it. So it generates this for all your copper. I believe historically someone's had to sit there and it was quite an artwork. Someone had to manually bend their copper up to match every curve, and then do it all manually without designing it first and without being able to pre-bend anything. There's also automated bend machines that you can export this from. So under export, I believe I'll be able to find it. Machining, and down the bottom here, NC copper. There's machines, or DXF copper. There's machines that will actually handle these input files and auto bend everything for you. Alrighty, last couple of outputs I just want to show you is the PDF output. This is obviously just the PDF. My DXF's at the end, the PDF of my project generated. And at the bottom here, we have the 3D. And this works really well with Adobe. And what it will allow you to do is when you send this to your customers, they can open up, have a look, and view the entire panel and shift it around and inspect whatever they want to inspect on it. Similar to that, if I was to jump, I'll just close Adobe, close all tabs. If I was to jump into, say, a CAD package, this is just FreeCAD, one of the packages I use, you can export the STP of your layout space and re-import it. If I was to just move this up and say, hide the door, we've got all the internal parts exported as well. This will allow you to generate exact models of your panels and then import them into, say, larger plant CAD files to match to mount the panel in the plant and say, look, this is going to fit exactly there. Oh, I've just mounted, I can see this fan's going to have, it's going to be right next to something that's going to conflict. You get that option as well. Yeah, obviously it can help by, as I said, just joining the production process. You can get all your copper bending done before the panel's even arrived. It allows you to increase the quality of your PDFs for your customers, and you can use that CAD output to fit back into larger CAD packages or have a look at it at a plant or site level. The last bit I'm just going to talk about quickly, no demo for this unfortunately, is the smart production. It's a very large topic, and we're going to do a future webinar on it, I believe. But it's looking at the Smart Production Suite by EPlan, and you can export directly to this from ProPanel, and it will generate a production file. Now, there's 3 modules in the Smart Production Suite: the Smart Mounting, which takes care of your DIN and duct mounting on a single page, and then it takes care of your item mounting. And what it'll effectively do was give you a list of every DT of every device. And by clicking on that, it'll zoom in on the 3D ProPanel generated image and show you that this device is exactly there and this is where you're mounting it. It's also got a process where you can go through and mark each device as you go, and that allows at a later date, if obviously if someone's got halfway through and left, then the next person can just pick up exactly where they've left off and know what's done, and gives you a checklist for everything has been mounted for that panel. Same thing with smart wiring. It lists every wire number, which is generated after the routing is complete. And you can go through and you can have a look at every wire, see where it's terminating from and to, and I'll actually do a little zoomed in kind of graphic or view and do a video almost running along the track of that wire to show you where it's mounted. So this speeds up your production once you've got the automation in place. One of the beautiful bits that goes with this is Smart Suite, and this will allow you to load up multiple panels of jobs, and then you can view the jobs even remotely, and it will give you a percentage completion for both your mounting and your wiring and your DIN and duct for that panel, so you can watch it be assembled or see where each job is. So it's a job tracking element to it.